proceed to the question number 2. A 3 kg box is pushed along with a smooth horizontal surface with a force of 9 Newton. Calculate the acceleration of the box. Second one, if the box is pushed with 12 Newton, what will be the new acceleration? So let's write down what are the data given for the question number 1. That means question A. We have mass is given as m equal 3 kg, 3 kilogram, and force is given as force equal to 9 Newton. 9 Newton. What we need to find out? We need to find out the acceleration. So acceleration, as you know, the formula is acceleration A equal to F over m. So which is equal to the force given as 9 over 3. So you will get which is equal to 3 meter per second square. Right? So coming to the question number B. Question B. If the box is pushed with 12 Newton, what will be the new acceleration? And what's given here already, the force is given. That means force F equal 12 Newton given, and we found the acceleration as 3 meter per second square. So the acceleration is acceleration A equal to 3 meter per second squared. So what we need to find out? So B part, what is given here as the force is equal to 12 Newton, and we need to find out the new acceleration. All right. So the mass already we have 3 kg. So the new acceleration A equal force over mass, which is equal to 12 divided by the mass given as 3. So 12 divided by 3 equal to 4 meter per second square. Okay. Now coming to question number 3, we have a 5 kg trolley is pulled with a force of 25 Newton. The frictional force opposing motion is 5 Newton. Calculate the resultant force acting on the trolley. So here, just imagine, I'll draw a diagram over here. Alright, a trolley is pushed with 25 Newton. And frictional force opposing its motion, that means it will be in the opposite direction. So 5 Newton is in the opposite direction. So how will you find out the net force or the total force or the resultant force will be? You need to subtract, right? So here it would be 5 Newton. So how will we find out the resultant force? The F resultant, R means resultant, F resultant equal to 25 minus 5. So the resultant force here you will get 20 Newton. Now, what else we need to find out in the B part? We need to find out the acceleration, right? So acceleration, as you know, the formula acceleration E equal to force over mass. So the forces, the resultant forces already we found, it is 20 Newton. So 20 over the mass given as 5. So if you divide 20 over 5, you'll get 4 meter per second squared. All right. Now, coming to the next question. The boxes show some physical quantities and their units. Draw a straight line from each physical quantity to its correct unit. One has been done for you. So let's see. So here the physical quantity is given and units also given, and one is already done for you. That means force, you know the unit is Newton. Now, coming to the velocity. Velocity, we know that the velocity, the unit of velocity is meter per second. Okay, so meter per second. Next, power. Power is what? Next, moment. Moment is, we know that moment is Newton meter. Next one is acceleration. Acceleration is meter per second square. All right, that's it. Question number 6. A car of mass 1200 kg accelerates uniformly from a velocity of 14 meter per second to 22 meter per second in a time of 5 seconds. State the formula linking acceleration, change in velocity and time. So first question, state the formula linking acceleration, change in velocity and time. So what is the formula here? Acceleration A equal final velocity minus initial velocity V. V means final velocity, initial velocity means U divided by time. This is the formula which links acceleration, change in velocity and time. Next one, we need to find out the acceleration. So for that, what do you need? You need the final velocity and the initial velocity. Just let's look at the question here. Here we have two velocities. So a car accelerates uniformly from a velocity of 14 meter per second to 22 meter per second. So initial velocity would be 14 meter per second and final velocity, that means V would be 22 meter per second. So the calculation for the acceleration here, A equal the final velocity is 22 minus 14 divided by the time. Time is given as 5. Alright, so 22 minus 14 equal to 8 over the time is 5. So if you divide 8 over 5, you will get 1.6 meter per acceleration. The unit of acceleration is meter per second square. Now, last question, using the acceleration found, calculate the unbalanced force acting on the car. And you know that formula for acceleration is F equal mass times the acceleration. The mass given as 1200 kg times the acceleration. We found the acceleration is 1.6. So 1.6 meter per second squared, which is equal to 19. If you multiply 1200 times 1.6, you will get 1920 Newton. You can use the scientific calculators in your examinations as well. Now, coming to the question number 7. A trolley of mass 2.5 kg is pushed along a rough horizontal surface. The applied forces are 15 Newton and frictional and air resistance force total 5 Newton opposing the motion. Calculate the resultant, that means the net force acting on the trolley. Using the second one, using the resultant force, calculate the acceleration of the trolley. So let's see the first part. That means calculate the resultant or the net force applied. Okay. So here, net force is, here it is 15 Newton and here we have 5 Newton. So therefore the net force would be net force equal 15 minus 5, which is equal to 10 Newton. And so the 10 Newton is the net force. And next one, using this net force, calculate the acceleration of the trolley. So how will you calculate the acceleration? Equal to force over mass, which is equal to, what is the force given? That is 10 Newton over the mass given is 2.5 kg. So 2.5. So 10 divided by 2.5 equal to 4 meter per second square. So that is the answer for the question number 7. Now, coming to the section C, question number 1. The information in the following table was obtained from an experiment with a spring of original, that means unstretched, length 5 centimeter. This is the original length. And here we have load force on springs in Newton. And next table column we have a length of a spring is given in centimeters. We need to find out the extension of the spring in centimeters. Alright, so this is the unstretched length and we need to find out the extension of the spring. So when you add the load, what will happen to the spring means it will extend, obvious. So if you add each load, the spring will extend. So the extension length is given here. So how we can find out extension of the spring here means it's pretty simple. You just subtract this number, that means the unstretched length, from each load added. Okay, so for example, here we have 5. This is the original length of the spring unstretched, and if you subtract this 5, so here we have 5 minus 5 equal 0. Second one, we have 5.8. Okay, so 5.8. So we need to subtract from the extended length to the original length, right? So here 5.8 minus 5, you will get 0.8. And next one here 6.5, that means 6.5, this one minus this 5, okay, minus 6.5 minus 5 equal, you'll get 1.5. 7.5, next one 7.5 minus 5, you'll get 2.4. 7.4 it is, okay, so 7.4 minus 5 equal 2.4. Next we have 8.3 minus 5, we'll get 3.3. 9.7 minus 5, we'll get here 4.7. Next we have 12.9 minus 5, we'll get 7.9. Okay, so this is the extension of the spring. So how did you get the extension of the spring? You just subtract the length of the spring from its original length. Okay, so that's the first part of the question. Now the second part is use your table to plot a graph of force. The force, we take it in the y-axis, and the extension we take in the x-axis. Remember, the force is in y-axis and the extension is in the x-axis. So if you plot the graph, you'll get a graph in this way. So this is the graph for the given data. So that is a Hooke's law question. All right. Now coming to the question number 2. A student uses this apparatus to investigate forces stretching a spring. So look at here. I hope you remember we have done this experiment in the class. So here we have a ruler and a weight which is extended from a spring, and this is the height from the ground level. Alright, so this is the added weight. So if you add more weight, what happened to the spring? It will extend. Very simple. Alright, now coming to the questions. Question number 1, suggest 2 ways that the students can measure the distance more accurately. Second one, the student continues her investigation by loading the spring with different masses. The table shows her results. Okay, let's go back to the experiment once again. This is the experimental setup. Have a look at this one. So this is the experimental setup. So first one, what we need to do is you need to suggest 2 ways in which the student can improve her reading or the measurement, how to get the accurate result. So first one, we can say the first one, we have many ways in which she can improve her reading. So first one, in easy and simple, we can say that take reading at eye level. Why we need to take a reading at eye level means in order to avoid the parallax error. So we are taking the reading to avoid the parallax error. That's why we are taking the reading at eye level. Now, question number 2. What is the question? Or we need to write 2 suggestions, right? So, second one, use a finer ruler. Use a finer ruler. Say, for an example, instead of centimeter, you can choose millimeter. So, in order to get the accurate result, you can use, instead of centimeter, you can use millimeter. So, this is the 2 ways in which she can improve her reading. So, first one is the take reading at the eye level, and second one, use your finer ruler. Instead of centimeters, use millimeter. Now, coming to the next question. The student continues her investigation by loading the spring with different masses. The table shows her results. So this is the table. And now plot a graph of distance, height against force, and draw the line of best fit. All right. So first one, we need to draw a graph against height. That means the distance. This is the distance, and against the force, this is the force. All right. So if you draw the graph for these given points, here you will get a graph in this way. So here, if you see, the distance is given, and here the force is given. Now, the last part of the worksheet is the momentum. You know that momentum formula is, momentum is denoted by the letter P, which equals mass times velocity. How will you find out mass from this equation? Mass M equal P over V. And how will you find out velocity? Velocity equal P over M, right? So first question, define momentum, state the formula of momentum and its unit, explain what happens to the momentum of an object if its velocity doubles, is momentum a scalar quantity, or explain why. See, all these questions we have discussed in our class. Please refer your notebook, textbook to get the answer for this section E. Alright, coming to section B question. A 4 kg object moves with a velocity of 3 meters per second. Calculate its momentum. If the object's velocity increases to 5 meters per second, what is the new momentum? All right, so we have to write down what are the data given here. Mass is given, mass equal to 4 kg, and velocity V is given, velocity is equal to 3 meters per second is given. We need to calculate the momentum. You know the formula to calculate the momentum. Momentum P equal mass times velocity. So here mass is 4 kg, so 4 times 3. Pretty simple, you'll get 12. And what is the unit of momentum? Kilogram meter per second. So that is the answer for question A part. If the object's velocity increases to 5 meters per second, what is the new momentum? So already we have the mass, M equal 4 kg, and the new velocity is 5 meters per second. So velocity V equal 5 meters per second. We need to calculate the new momentum, right? So momentum P equal mass times velocity, which is equal to 4 times 5 equal 20 kilogram meter per second. All right, coming to the second question, two ice skaters push each other apart. One is heavier than the other. Explain which skater will move faster and why in terms of momentum. Okay, we know that momentum P equal momentum P equal mass times velocity. That means mass is proportional to the momentum, velocity is proportional to the momentum. Here, the heavier skater pushes a lighter skater. So, which one will move? So, obviously, since the lighter skater has a smaller mass, they must move faster to have the same momentum as the heavier skater. Therefore, the answer is the lighter skater, the lighter skater lighter skater moves faster. Moves faster. All right. So that is the answer for the question number 2. Now coming to the question number 3, why is it difficult to stop a fast-moving train compared to a bicycle? This also related with momentum. As we know, we can write the equation for momentum as momentum P equal to mass times velocity. And a train has a much larger mass and often a high velocity, so its momentum is extremely large. So to stop it, a large force or a long stopping time is required. That's why it is difficult to stop a train compared to a bicycle. Clear? All right, coming to the next question. The photograph shows a dummy during a test of the safety features of a car in a collision. Before the collision, the dummy in the car is traveling at a velocity of 14 meters per second. The dummy has a momentum of 1100 kilogram meter per second. Question part, state the formula linking momentum, mass and velocity. Show that the mass of the dummy is approximately 80 kilogram. All right. So we know that the formula for momentum is P equal mass times velocity. Now coming to the second question, so show that the mass of the dummy is approximately 80 kilogram. So from here, we need to calculate the mass. So use the triangle method. Hope you remember the triangle method. If you don't, I will draw it here. Momentum P mass times velocity. Okay, so this is a triangle. Now we need to find out the mass. So mass is equal to momentum over velocity. So we can write here mass is equal to momentum, that means P over velocity. So momentum is given as 1100 divided by the velocity given as 14. So if you divide these two numbers, you will get approximately 78.5, so which we round it off into 79, which is pretty close to 80 kg. So that is the answer.